Alright, so we're going to be starting the next chapter, chapter 10, which is planning for retirement. We have a lot of definitions in this chapter and a lot of examples that are a little difficult, so you may need to pause the video at any point in time to kind of copy some things down. But retirement, that's a point when a person stops working. Semi-retired is when someone retires from their main job but may work part-time somewhere else. Pre-tax and after-tax investment. Pre-tax is a deposit made to a retirement account that is taken out of wages pre-tax. So before they take tax out, they take out any retirement investment that you make. After tax, this is money deducted from your income after taxes. So you can't be taxed twice. So you're either going to be taxed at the beginning or at the end, depending on when you set up your account. Types of accounts. You have a traditional IRA. Okay, this is tax deferred until withdrawn and taxed at the end. Okay, so you'll put money in, no tax taken out, but then when you want to use it, when you're 59 and a half, that's the time where you can take it out without penalty. That's when you're taxed. A Roth IRA, this is taxed at the beginning, so when you take it out at the end, you're not taxed. A 401k, this is a retirement plan for employees. This is tax deferred money, so this is money taken out pre-tax. And it's typically matched by your employer. So if you put in a specific amount, your employer may match that amount. A KEOG plan, this is a retirement plan for self-employed. A 403b, similar to a 401k, but the category is different. This is a retirement plan for educational institutions or non-profit organizations. So for example, myself, I have a 403b. This is a retirement plan for a teacher. So if you need to pause the video, go ahead. We're going to go on with our examples. We have two formulas that we're going to be using. We have a future value of periodic deposit investment, and we have a present value of a periodic deposit investment. The formulas look very intimidating, but they are not too bad because the values are set. So all you do is you plug in your numbers, put them into the calculator, and it basically shoots out the answer for you, as long as you know what each letter means. B is your balance at the end of the investment. P is your periodic deposit amount. This is how much you initially put in. Your R is your annual interest rate as a decimal. So it's typically a percentage. You convert it to a decimal. N is the number of times the interest compounds per year. It'll tell you that in the problem. And T is the length of the investment in years. So all you do is you plug those numbers in, and it looks intimidating, but it's super easy once you plug those numbers in, and we'll show you that. And then we also have a present value, so it depends. The first formula is the typical one, all right? So we'll show you that with some examples here. All right, number one says Ricky is 35 years old. He plans to retire when he is 63. He has opened a retirement account and pays 3.2% interest compounded monthly. Monthly means once a month, so that's 12 per year. If he makes monthly deposits of $400, how much will he have in the account by the time he retires? So this is future. That's why it's set up as the B. All right, so we have $400 is your investment each month. So that's P. 1 plus 3.2% as a decimal is 0.032 divided by 12 because it's compounded monthly, and we raise that to N. N is the number of times it compounds per year, which is 12 once a month, times T. All right, 35 years to 63 years is 28 years. So 28 minus 1, and then over again your rate divided by 12. When you put this into the calculator, so I would do the top first, get an answer, and then divide it by the bottom fraction. You'll get roughly $217,029.69 after 28 years. Okay, number two. At age 30, Jasmine started a retirement account with $50,000, which is compounded interest semi-annually, so that means twice a year. with an APR percentage of 4%. She made no further deposits after 25 years. She decided to withdraw 50%. Okay, and then she had to pay a 10% penalty for early withdrawal. All right, so we're going to use our formula again here. This is the compound interest formula, which is part of the formula. So again, you can kind of refer to your notes here. Initial deposit of $50,000. 1 plus 4% as a decimal is 0.04. Compounded semi-annually, so twice a year. Raise it to compounded semi-annually, so 2 times 25 years. So it says after 25 years. You work that out, you get $134,579.40. She decided to draw 50% of that, so cut that in half, so multiply it by 0.50. You're going to get $67,289.70. And then on top of that, she had to pay a 10% penalty. So multiply that by 10%. And her penalty was $6,728.97. Okay. Number 3. Laura has been contributing to a retirement account that pays 4% interest with pre-tax dollars. This account compounds interest monthly. She has put $500 per month into the account. At the end of 10 years, she needed to pay some medical bills and has to draw 15% of the money. Okay, so again, initial deposit of $500. 1 is always set value, plus 4% as a decimal is 0.04. This interest compounds monthly, so that's 12 times per year divided by 12. Raise it to the 12th, all right, for compounded monthly, times 10. It says at the end of 10 years, so times 10. So T is 10, minus 1, that's a set value, divided by your percentage over 12. So 0.04 divided by 12, because it's, again, compounds monthly. You get 736.24.90. She has decided to only draw 15% of that, so multiply that by 0.15. So she is withdrawing $11,043.74. Part B, Laura pays 23% of her income taxes. What was her tax in the amount that she withdrew? So you take your $11,044, I just rounded it up, multiply it by 0.23, because she has to pay tax on that amount that she took out, and you get a tax of $2,540. She also had to pay a 10% early withdrawal fee. So take $11,044 times 10%, and she paid a early withdrawal penalty of $1,104. So notice that the tax and the withdrawal money comes out of the actual amount that you take out. Number 4. John is 60 years old. He plans to retire in 2 years. He now has $400,000 in a savings account that yields 2.9% interest compounded continuously. He has calculated that his final working year salary is $88,000. He has been told by his financial advisor that he should have 60 to 70% of his final year's annual income. So his final year's annual income is $88,000. So we're going to find 60% of that, so 88,000 times 0.60, and we're also going to find 70% of that because his financial advisor told him that he should have between 60 and 70%. So 60% of 88,000 was 52,800, and 70% of 88,000 was 61,600. So somewhere between that he should be saving 52,800 to 61,600. He should be saving somewhere in that range. Part B, a new formula here. Okay, use a continuous compounding formula, which is in a different chapter, so that's why I kind of refer to it here. Again, it's going to be in your notes, so you can always refer back to it. P is your initial investment, so $400,000 was our initial investment. E is a set value. It's actually a button on the calculator. It's a set numerical value. R would be your rate, so 2.9 as a decimal is 0.029. And then after 1 year is your T value. Okay, so So when you multiply all that out, you're going to get $411,769.84. Okay, that's for your first year. Now after your second year, the only thing that changes in your formula is T. T becomes 2 because you're talking 2 years down retirement. Okay, so after 1 year, that's how much he has. After 2 years, he'll have $423,885 in his retirement. And part C, assume that John is planning on using 65% of his current salary in each of his first 5 years of retirement. What should his annual amount be? So you're going to take your $88,000, which was your final working year salary, and multiply it by 65%. So that number is going to be $57,200. John has decided that he will need $20,000 each year from his savings account to help him reach his desired annual income. Will John be able to make withdrawals of $20,000 from his savings account for 20 years? Explain your reasoning. So $20,000 times 20 years gives you $400,000. Okay. So after his second year of retirement, if you remember up from above, he had $423,886. So clearly, $400,000 is less than $423,886. So he has enough to withdraw $20,000 for 20 years. Okay, number 5, we're going to refer to number 10 on page 615, which is off to the side. It said Jack contributed $400 per month into his retirement pre-tax. His taxable income was $62350. He files taxes as single. So you're going to have $400 per month. So 400 times 12 gives you $4,800. Your taxable income is $62,350 from the problem, plus $4,800 because it's pre-tax, so it didn't get taxed on it yet. So we have to add it to our total income. So a total income of $67,150. Use the tax table on the right to determine his pre-tax and after-tax contributions. So $62,350 is right here. Okay, so you're going to pay a tax of $11,388. All right, that's pre-tax. Now after tax is $67,150. So that value is right here. That's going to be $12,588. So how much did Jack save in taxes during that year? All right, he saved $1,200 when you subtract the two. Okay, and then we're going to refer to number 12 in the textbook. Giovanni is a 40-year-old executive for a department store. She files taxes as a head of household. She needed to withdraw $45,000 from her tax-deferred retirement account to make a down payment on a new condo. Her income in her final year was $110,550, excluding the $45,000 early withdrawal from her retirement. So $110,550. That falls between $100,000 and $129,600. So that's going to be taxed at a 25% rate over here to the side. Okay, right here in this row. So 25% of that income, okay, gives you $27,637.50. And we're going to subtract off our minimum tax of $5,677.50 for a total amount of $21,960. Okay, now if you add on the $45,000, that income goes up to $155,550. That's your second row. That's going to be taxed at 28%. So you'll notice that as your income goes up, your tax rate goes up as well. You're going to pay a total tax for that one of $33,988. How much more tax? Well, you just take the two taxes from A and B and subtract them. So you're going to pay $12,028.50 more in tax when you include your income. And the early withdrawal fee, 10%. So $45,000, that's what you took out early from the problem, times 10% gives you $4,500 in a penalty. And that is it for day 1.